Hello again. This new class will be about code checking and design. After the structural analysis, you can select any of the available codes in the software for reinforced concrete, structural steel, processed concrete. By default, the selected codes are the Euro codes, but you have a complete list of available ones. For this, the list for reinforced concrete, this is the one. For structural steel, you have the main and most important ones, which are the American and European, but as well you have the Chinese, Indian, and other codes. And for pre-stressed concrete, the check process will analyze the ratio of the demand and capacity of each member of each cross-section will be calculated for each cross-section of the beam element for the Y and J ends. For the case reinforced concrete, the interaction diagram will be calculated for each cross-section using the pivots of the material, and for steel structures, this ratio of demand and capacity, which is the total criterion, will be calculated depending on the checking type, if it's in tension, under shear loads, bending, or combined forces and moments, according to the each code specifications. For the check and design process, you can select another design stress and strain diagram, different from the analysis stress and strain diagram for steel and concrete and pre-stressed concrete checking. Of course, you will need more data to proceed with the checking and design, which are parameters or properties. You code the safety factors, partial safety factors, steel yield strength, strains, and for concrete, depending on the code as well, you will have different resistance and strength characteristics. You will have default values, but you must check they are the ones you need for your calculation. You will have new files after the check and design process. You will have new result files after the check and design processes, and will give you the typical code and standards results. Class of the section, class 1, class 2, 3 or 4 for Euro codes, or compact, non-compact, slender for the American steel codes, design values and resistance, the total criterion, if the cross-section is safe or not safe, interaction diagram, etc. For steel structures, there is a member check verification, which means that each cross-section of the beam, depending on the loads, this example you have the axial and bending moment, this is the combined forces. It will evaluate these forces. Numerators are the forces and moments in the section, including the safety factors, and the denominators are the resistance and strengths of the cross-section, which is the capacity. Of course, these terms are calculated depending on the class of the section and the type of the load. For shear, buckling, you have different formula, but at the end you obtain a kind of safety factor, a ratio. If it's above 1 or below 1, that will give you if the section is okay or not okay. That's for the Euro code. For American codes, for the AISC codes, the required strength must be below the design resistance, or that required strength must be less than the allowable strength. So the ratio must be below 1. For concrete, it's similar, but in this case, we take into account interaction diagram of each section. The calculation of the bending moment and axial force pair, including reinforcement or without reinforcement, the ratio of the point, if it's inside or outside, will give you the result of the criterion. If it's out or inside, the total criterion will give you below 1, the forces and moments are lower than the ultimate strength. That will be a valid okay section. If it's above, it means that the point is outside and you have to redesign the section, setting a different reinforcing steel amount or increasing the dimensions of the cross-section. New files will be obtained. First, you have to select an RCF file and then perform the code checking. The name will be something like this, with this extension, CRCF, the name of the load case. The code will depend on if you are using the American or Indian or Chinese or European code. Of course, you can change name always. And then type of checking, if it's bending, shear, combined buckling for steel. And if you are using concrete sections, you have if it's axial shear, and method if you are checking or designing shells. You will have as many new files, as many checking or design processes you perform. And of course, you have many examples. You have a concrete slab in the work example section, a tapered arc rebar as well, a concrete frame, and for steel, you have this steel walkway, Regency Hotel walkway, and now we will show you this example. If we want to perform code checking or design, we have for concrete beams these options for checking. The difference of checking and design according to codes is for checking, the software will verify the reinforcement that the user has defined and will give a criterion, okay or not okay, if it's enough or not. And with the design, the software will provide the amount of steel for axial or for shear and torsion that the section needs for each finite element in order to meet the specifications of the code. In this case, the default code is the Eurocode number 2, the European code. So if I check for bending, I can select the different planes. In this case, we have a biaxial plane because applying forces in both planes. Well, in this case, I will check better if I want to check for ULS. For axial, click OK, and we have a new result, which is our new result. It has a new extension and with different results. In this case, we have the criterion, which will give you the safety factor of each section. If it's below 1, it's okay. If it's above 1, that section that need to be redesigned. An amount of steel or the dimension of the concrete section, they must be modified. In this case, the worst section but are the ones here, but they are still okay. These elements, we can plot the interaction diagram of this section. The criterion for the 2D case will be the ratio of this first distance between the green point to the purple point divided by the distance between the green point center of the diagram and the external point in blue, the ratio of the external actions and the ultimate strength. So it will give you the capacity of the section, and if it's below 1, the section is okay. The software will do the same for each section and will give you the total criterion. If we go to our sections, we go here and we can check the reinforcement that they are the amount of reinforcement defined. You can see more details in the PDF located in the worked examples section, and you can see here the different reinforcement that it has defined. For these sections, there are 12 bars, 32 millimeters of diameter. These structural elements have these tapered sections 3 and 2, and they have this rebar configuration. If we perform a design, we have these properties. Important parameters to set is the minimum and maximum amount. This coefficient will be multiplied to the actual amount of steel of each section. It can be divided or multiplied, the minimum and maximum. It will multiply the amount of reinforcement set each cross section, so we can ask the software to find reinforcement half of it or 10 times the ones defined. But which ones? Okay, which sections? Only which reinforcement? Only the reinforcement which was defined scalable here. By default, all reinforcement configuration is scalable, but maybe you want to fix only one group, set minimum reinforcement, and then let the software to look for the factor of reinforcement. You have it here in your result, the design, and as the criterion gave us before a value below 1, now we have here a factor that it says that if you multiply or you reduce your reinforcement in half of it, the reinforcement which was defined as scalable, that will be enough to fulfill the code specification. That's for this load case. We can perform a design or a check for each load case, and then again perform an envelope or whatever. Thank you very much. Stay tuned and see you in the free course.